I am Professor Rajendran, trying to make an attempt to make the student understand trigonometric equation, how best it is being used in engineering mechanics. And this is the base and fundamental for any student. So far I have met about 4,000 to 5,000 students. Many of them ignore this portion at 10th standard or at +1 and +2, and thereby the students who are joining at engineering stream finding it very difficult to understand engineering mechanics. This trigonometric equation applied on engineering mechanics is a base and fundamental requirement for any student who is willing to join engineering stream. Let us look. ABC is a right angle triangle where angle B is 90 degree and we assume angle A is theta and assume angle C is alpha. In any triangle ABC, this 90 degree angle B plus theta plus alpha is 180 degree. Or otherwise, you can say angle A, angle B, angle C is 180 degree. Since it is a right angled triangle, the angle is 90 degree. We say 90 plus theta plus alpha equal to 180 degree. And thereby we get theta plus alpha equal to 90 degree. And as per Pythagoras theorem, AC square equal to AB square plus BC square. So this two information initially one should know. I am trying to concentrate only on resolving forces. There are many other properties in triangles are available. We will see later on. We have been telling about the right angle triangle ABC, and we are also assuming that angle B is 90 degree because it is a right angled triangle. The side AC opposite to 90 degree is hypotenuse, which is called hypotenuse. And if you take alpha as a reference angle, that is angle C is an alpha, we assume now, then BC become adjacent side, then AB become opposite side. Please note, opposite side and adjacent side are referred with respect to the angle under consideration. Here alpha is the angle we consider, thereby AB is opposite side, BC is adjacent side. The side AC, which is opposite to 90 degree, is hypotenuse. Now let us look the same right angle triangle. Angle B is 90 degree. Now we consider angle A as a theta. If we consider angle A as a theta, with reference to theta, BC going to be the opposite side and AB is going to be the adjacent side. And as usual, the side which is opposite to 90 degree is hypotenuse. You may note that this hypotenuse does not change whereas the adjacent side opposites are changes with the reference to theta. So it's one should note adjacent side, opposite side, both adjacent side and opposite side changes with reference to the angle we assume are given. Hypotenuse side is a side opposite to right angle is 90 degree, which does not change with reference to the angle assumed, either theta or alpha, or the angle we assume. Let us consider the theta now. Sin theta, this is a formula one should remember, opposite side by hypotenuse. That means we have already seen, referring the theta, opposite side is BC. So BC and hypotenuse AC. Similarly, cos theta is adjacent side by hypotenuse. Now when referring theta, adjacent side is AB. So AB by AC is the cos theta. Here let us take alpha an angle. In this case, sin alpha equal to opposite side by hypotenuse. Formula remains same, but the opposite side with reference to alpha is changes to AB. AB by hypotenuse AC. So similarly cos alpha, the formula remains same, adjacent side divided by hypotenuse, but the adjacent side is changes when we are referring the alpha, that is BC by AC. Now we know that sin theta equal to BC by AC and cos theta equal to AB by AC. That is BC is opposite side by hypotenuse, cos theta adjacent side by hypotenuse. Now another formula, tan theta equal to sin theta by cos theta. You substitute the sin theta value and cos theta value here, the hypotenuse get cancels. The formula reduces to opposite side by adjacent side, or which is equal to BC by AB. Finally we get tan theta equal to BC by AB. This also one should remember. We have already seen that sin theta equal to opposite side by hypotenuse. Suppose you want the opposite side BC. BC equal to sin theta into AC. Otherwise, sin theta into hypotenuse side, this hypotenuse side. Similarly, we know that cos theta equal to adjacent side AB by hypotenuse AC. From that, if you want adjacent side, then you get cross multiplied these two. So AB equal to cos theta into AC, that is AC is hypotenuse. Earlier we have seen considering the theta. Now let us see considering the alpha. Here sin alpha formula remains same, adjacent side by hypotenuse. Sin alpha opposite side by hypotenuse. So your AB is here is opposite side with reference to alpha. So if you want this AB, you get sin alpha into AC. Similarly, if you want BC, you get cos alpha into AC. That is hypotenuse. AC is a hypotenuse. Now in this problem, I simply replace AC as 100. So you get AB again, AB equal to sin alpha into 100, where we consider the alpha. Similarly, if you want BC, BC cos alpha into 100. Last slide, we have seen the same triangle here. So, since I have replaced 100 into 100 kilonewton, this gets BC equal to cos alpha into 100 kilonewton and AB equal to sin alpha into 100 kilonewton. This triangle can be changed like this. If you note that 100 kilonewton remains same, BC, this horizontal line also same, the value also same, and I just replace this green line to the direction as shown there. If you draw a rectangle, this side equal to this side. That is why the value of AB is here. So this figure is equivalent to this figure. Please note here, I have given the directions. Here arrow mark is shown there. That means there is a 100 kilonewton is acting in this direction. And as usual, these values remain same, no changes. Please note, if an object is here, if there is a force acting on this line, the body will tend to move this direction. So this final explanation about the force we will see in the next slide. Now we see that force 100 kilonewton is acting on this direction, or this force 100 kilonewton is getting divided into a vertical component and horizontal component. So vertical component of this force, when it makes an angle of alpha, then you get sin alpha at 100 kilonewton, cos alpha into 100 kilonewton. Force is a vector quantity and hence magnitude and direction is necessary. Here 100 kilonewton is the magnitude of force and alpha is the direction acting on it. It is to be noted that single force, this 100 kilonewton, is getting resolved into two forces, that is vertical component, horizontal component. This concept is very much useful in solving problem engineering mechanics, considering the equilibrium condition of statics as well as dynamics. We will see further application of this simple formula in solving the engineering mechanics problem. Thank you.